Hello, everyone. Thank you. Welcome to the Geo 6 session. We're going to start off a little bit differently than perhaps you might have anticipated. We're going to look at the future of Geo, and we're going to look at issues of satellite data, global observation for the benefit of the environment. And we have some inspirational speakers here today from St. Scholastica School who will talk about their experience with the GLOBE program. And we are calling them junior scientists because that's what they are in the GLOBE program. They're called junior scientists. And we are very glad to have them here today. Then we will move on to the presentation of the regional assessments, which have just been released for the Geo 6 regional assessments. And we will have a presentation of the global gender environment outlook as well. So I hope that's very interesting for you. And we'll launch this morning or this afternoon with Stephen Kamau, who is the teacher at St. Scholastica School, who is going to present the students who will present the information. Thank you.
Good afternoon. Thank you, Mr. Pierre. I would also like to thank Priyanka D'Souza, who has given us this platform. My name is Stephen Kamau, a GLOBE teacher at the St. Scholastica Catholic School. And with me here I've come with a group of young junior scientists. There are many in our school, comprising of around 50. But here we have just representatives. On my left here we have Regan Gakungu. Next to him we have Soro Karna, who is a 6th grader. We also have Christine Karuba, an 8th grader. And lastly, Joy-Ann McKenna, who is a 5th grader at our school. Our school is situated in Nairobi, and we are glad to be in this forum. We'll start with a short video, which will essentially talk about the GLOBE program, which is a worldwide science and education program. So if you give me your ears, and at least we just listen and get to know what is GLOBE, it will be very good. Thank you. Sorry for that. Yeah. The sound. Okay. Then at this juncture, let me call upon our first presenter, that is Regan Gakungu, who will continue with the presentation. They will talk more about the GLOBE. Welcome, Regan Gakungu.
Good afternoon. Good afternoon. My name is Regan Gakungu from St. Scholastica Catholic School. I'm in the 7th grade, and I'm going to present section 1, which is the introduction to GLOBE. GLOBE. GLOBE is an acronym for Global Learning and Observations to Benefit the Environment. GLOBE students build understanding by doing environmental observations and asking questions. Students collect and analyze their data, as shown in the first picture. Young scientists from our school are conducting the pH levels of River Madare, which is near our school. And in the other picture, we can see a teacher and her students doing some laboratory tests. Students upload their data to the GLOBE database, where research scientists may access and know the conditions of different places. Students and scientists can download the reported data in different formats, such as raw data, which is tabular, time series, which is graphs, and spatial, which is maps. When our research is over, students around the world can report on the outcomes of the investigation in science fairs, where we can tell other students how we are doing, and we can also learn from how they are faring. Students from no matter anywhere in the world, we use the same procedures developed by research scientists, and these procedures are known as GLOBE protocols. I'd like to conclude my presentation from here and welcome my fellow colleague, Soro, who's going to continue with section 2, which is dealing with GLOBE protocols. Thank you.
Good afternoon. My name is Soro Karna. I'm from St. Scholastica Catholic School. I'm in grade 6. I'm an Ivory Coast national, and I'm here to present section 2, which is GLOBE protocols. GLOBE science investigation areas. GLOBE has 4 main investigation areas, namely the atmosphere, which is the air, the hydrosphere, which is water, the biosphere, which is life, and the pedosphere, which is soil. The atmosphere. In the atmosphere, us GLOBE students investigate the aerosols, the air temperature, the barometric pressure, the clouds, the surface temperature, the water vapor, the wind, among others. As we see here in the first picture, we have some of our young scientists from our school collecting data on the cloud cover. And here we see a scientist explaining to our young scientists how we can use our automatic weather station to collect data. The hydrosphere. In the hydrosphere, we conduct tests to measure the acidity, the conductivity, the dissolved oxygen, the freshwater microinvertebrates, the mosquitoes, nitrates, water temperature, water transparency, and the water pH levels. The biosphere. The biosphere includes something called biometry, which is the study of life. In biometry, we investigate the canopy and the ground cover, the land cover classification, the seasonal changes, and the bird migration. And finally, the pedosphere, which is the soil. In the pedosphere, we investigate the bulk density, the soil characterization, the soil fertility, the soil infiltration, soil particle size distribution, the soil pH levels, and among others. I would like to conclude my presentation from there, and I would like to welcome one of my colleagues, Joy Ann McKenna, to continue with section 3, which is cloud protocols. Thank you.
Hi, good afternoon. My name is Joyanne McKenna from St. Scholastica Catholic School. I'm in grade 5 and I'm here to present cloud protocol. Clouds are the collection of water droplets. They are formed by a process known as condensation. As you can see in this diagram, hot air has evaporated, condensed into clouds, fallen as rain through rivers and back to the ocean. The process is known as the water cycle. We use the globe cloud chart to identify the types of clouds. We normally do this at solar noon. We check whether the sky is clear, cloudy, or obscured. If obscured, we check whether there is dust, haze, smoke, and many others. We identify clouds by shape, height, and whether they are rain-causing clouds. The cloud triangle is a useful memory device. The three main clouds shapes are cumulus, which are puffy, stratus, which are layered, and cirrus, which are wispy. The high clouds are cirrus, cirrocumulus, and cirrostratus, which are above 6 kilometers. The middle-level clouds are altocumulus and altostratus, which are between 2 to 6 kilometers. The low-level clouds are stratocumulus, stratus, and cumulus, which are below 2 kilometers. The rain-causing clouds begin with the name nimbo. They are cumulonimbus and nimbostratus. Cumulonimbus brings heavy rain, which is sometimes accompanied with lightning and thunder. Nimbostratus brings steady rain. As you can see in this diagram, cirrostratus, cirrus, and cirrocumulus are the high-level clouds. Altocumulus and altostratus are the middle-level clouds. Stratus, stratocumulus, and cumulus are the low-level clouds. As you can see, cumulonimbus is able to extend for a long distance. I now call upon Christine Karuba, who is going to continue from where I've left. Thank you.
Good afternoon, everyone. I'm Christine Karuba. I'm in the 8th grade, and I'd like to talk about Section 4, which is Globe Data Entry and Current Initiatives. Cloud fraction. You have to select 4 students who will be standing in 4 quadrants. Each of them should be facing the north, the south, the east, and the west. In recording cloud data, we record the cloud coverage according to percentages. As you can see in this picture, we have young scientists from our school collecting the cloud data. As I explained earlier, one of them is standing facing the north, the south, the east, and the west. And we have the student holding the reference chart, and we have the recorder. It's question time. I'd like to have 4 individuals to please stand. 2, 3. I'd like for you, madam, to identify cloud type A.
So it's not nimbus. It's not
cirrostratus.
Yes, with a bit of stratus in the middle. Very good. Yeah.
The cirrostratus. The cirrostratus clouds are layered, as you can see in the picture. I'd like for you, madam, to identify cloud type B. It's a good attempt, but it's the cumulonimbus. The cumulonimbus clouds are gray in color, and they are rain-bearing clouds, as you can see. And I'd like for you, madam, to identify cloud type C. It's a good attempt, but it's the altocumulus. The altocumulus clouds are middle-level clouds. And I'd like for you, madam, to identify cloud type D.
I have no idea. It looks like a dust storm.
It's the altostratus. The altostratus clouds are clouds covering the sun, as you can see in the picture. They obscure the sun. Next. After the collection of the data, we can record it in the cloud. We can record it in the cloud report, where we later transfer it to the Globe website. First, you enter the time and date. After that, if it's cloudy, you indicate whether it's cloudy. And after that, you'll be shown a reference chart, which will show you the type of clouds that you see outside. Then you'll select. Then after that, you can send it to the Globe website. There are three main options you need to know on entering the data on the Globe website. First, we have the mobile data entry. The mobile data entry is found in the App Store. Second, we have the live data entry, which is found in the Globe website. And third, we have the email data entry, which is found in the email. Some of the questions us young scientists encounter are like, first, how much does cloud cover affect surface temperature and surface air temperature? Second, what is the relationship between cloud and precipitation in weather prediction? Third, is there a relationship between controls and cloud cover? Fourth, how will clouds respond to changing climate? And many more. In our school, we are participating in a number of initiatives like cloud data collection, precipitation and rain data collection, monitoring water quality, and monitoring air quality, which was recently installed by the UNEP. In the first picture, we have young scientists from our school collecting the rain data from the rain gauge. And in the second picture, we have a scientist and young scientists being shown on how they can use the automatic weather station. Monitoring the health of Madare River. In our school, we are working in a number of perimeters on water quality. First, we have water temperature, which we use the thermometer, water pH, which we use the pH meter, and water conductivity, which we use the conductivity meter. In the first picture, we have young scientists from our school collecting the water temperature. And second, we have young scientists from our school collecting the water pH. In the second slide, I'm going to play for you a clip which will show us young scientists collecting the conductivity.
Reduce a little.
It is already open.
So you can return. On left in the camera. So 28. That means it's 2 microsiemens. 29.
Microsiemens per centimeter. 28 to 29. So let's reading 29.
29. Productivity plus 1 is for how long?
29 microsiemens per centimeter.
Record that. Record 290. 290. What want to record?
Now pour then you
In monitoring the atmospheric conditions, we need the automatic weather station. In our school, we have the automatic weather station where we can get to collect more data. Here we have the rain gauge, which collects the amount of rainfall. We have the temperature sensor and the humidity sensor. We have the wind vane and the anemometer. The wind vane measures the direction of wind and the anemometer measures the speed of wind. And we have the data logger, which collects all the data from the instruments and later can be transmitted to the GLOBE website. Here we have a graph showing the findings we have been collecting, researches we have been doing for last March. The amount of rainfall we recorded was 40 millimeters, and the temperature was 25 degrees Celsius. And if you want to get more information, you'll use the website shown below. We are undertaking a study to explore whether changes in temperature, precipitation, and humidity can affect the influenza cases at the Uzima dispensary near our school. Here we have a graph showing the precipitation and correlationship between the precipitation and the flu cases. When the precipitation levels drop, the flu cases increase. This is probably due to dust. This research, we have been doing it for the last 6 months, and we are still ongoing with more researches, which will probably do it for the next 1 year. Now I'd like to welcome Mr. Charles Mwangi to continue with section 5, which talks about research and collaborations. Thank you.
Ladies and gentlemen, good afternoon. My name is Charles Mwangi. I'm the Deputy Country Coordinator of the GLOBE program. We are going to run a small video that explains what GLOBE is, and then I'll take it from there. Thank you.
GLOBE is an international partnership that takes sort of students, scientists, and teachers and puts them all together so that the students will actually learn actual science and help study their environments.
First of all, the teachers go through a training situation where they learn all the protocols, how to present the information in class, and a protocol is basically a method of doing a piece of science research.
We also hope that the participants will get a chance to explore connections between the different systems of our planet, and most importantly, get to know each other and have fun.
Satellite imagery is connected to all the protocol areas. Basically, it gives you kind of a map or a starting point.
We have 4 main spheres on our planet. We have the atmosphere, which is, the clouds, the air, all of that. We have the hydrosphere, which is all the water bodies of the planet. The pedosphere, which is the world's soils, and we also have the biosphere, and that's all the living things on the planet.
Earth's environment is actually a complex system of systems. Each one of these is in and of itself a system that's a component of the large overall system.
When I've worked with teachers and sort of shown them the wonderful things that they can do with the satellite data, one of the things that they love is that they come back to their own community, and the students come back to their own community. They get to see what a satellite sees. I think one of the things that I love best about GLOBE is that it is so international in scope, and I really, really love when students themselves get to, A, learn about their community, but also share their community, their lives, their culture with students from all over the world. I think that's just magic.
So thank you. Globe is essentially a platform that we've given to the kids, as you've heard from the presentation of the junior scientists. We are trying to ensure that what they learn in school, they get to implement out of the classrooms. And that is also where we have a platform where they are able to do a number of research under the protocols. We have a number of the protocols that are available. And that is where now we partner also with the scientists, and we're also appealing to the scientists who are here to join the GLOBE program so that they, again, can help us mentor to the kids. The data that is collected by the GLOBE student, because it meets particular standards that are set by scientists, so it's available to you, the scientific community, for research. If you want to access it, you get it from the GLOBE website. Again, if you want to participate or to become part of the GLOBE program, you can join the network of the students. We have a number of missions that we are participating in because, again, the GLOBE program tries to involve the kids in actual science. We have missions like the SMAP, Soil Moisture Active Passive, that you're going to hear about in a few minutes. So what it does, it involves the kids to collect data so that, again, they are able to validate the data that is collected from the satellites. When you have ground truths, then the data that they collect fed into the GLOBE platform is available to NASA scientists to be able to validate whatever satellite missions they have. And again, we also have another mission that is coming up, the GEOs, that we're also going to involve the kids in that mission. I would want to request, before in the interest of time, we want to invite Erica. She's a NASA scientist who's going to Skype in to give more insights on the programs that are running, on the SMART program. As she gets online, we have a number of initiatives that are running. There is the TAMO, which was mentioned by the kids. We also have the UNEP air quality mission that is ongoing. So Erica is online. She will do a small presentation, and then I wrap it up at the end after she's done her presentation. Thank you.
Okay, Erica, your presentation is online.
Hello. Good afternoon. My name is Erica Podas, and I'm a scientist with the Earth Science Division at NASA's Jet Propulsion Laboratory in California. My research focuses in part on the study of the water cycle of terrestrial ecosystems using satellite data. And I'm a team member of the Soil Moisture Active Passive satellite mission. So today, I will give you an overview of SMAP and our partnership with the GLOBE program. Okay, so this is an illustration of NASA's Earth observing fleet. All of these satellites observe the different components of our Earth's environment related to the atmosphere and the continents to provide a big picture perspective of our Earth as a system. This fleet consists of 20 Earth observing missions, and SMAP is the most recent addition. SMAP was launched a little over a year ago, on January 31st, 2015. Its purpose is to measure soil moisture globally every 3 days. To make such measurement, it uses microwave technology, which allows us to see the surface of the Earth regardless of almost any kind of weather condition or day or night condition. So you might be wondering about the importance of soil moisture. It plays a critical role in weather prediction, flood and drought forecasting, and assessment of crop yields at the end of the season. It also helps us better predict areas at risk for vector-borne diseases because some mosquitoes like to breed soils that are either moist or very wet. Since soil moisture changes quickly, only way to monitor its dynamic nature and globally is through satellite. So the next video is a brief overview of SPF and its different applications. Okay, so this next video animation shows SPF soil moisture from mid-April to mid-August. So over the land, the yellow colors are areas where it's dry, and the blue colors are areas where it's wet. White areas are those that are masked out of the presence of ice. During the time period, sure. All right, so SMAP and GLOBE are partnered through the satellite mission. So GLOBE collects moisture measurements that we then use to calibrate, validate what the satellite is measuring. And you can learn more about our programs through the websites listed here. And I'd like to close by saying that every day we're learning more and more about our Earth. And we're putting together parts of the puzzle. Satellites provide a great deal of information, but there's still gaps in information that citizen scientists have to play a critical role in understanding. Thank you.
The audio was not very good, but essentially what we want to propagate is to propagate science that is meaningful to the kids. Like the junior scientist mentioned, we are looking at different parameters. You have the atmosphere, hydrosphere, biosphere, and the pedosphere. All that data is collected, and when you have a network of schools, then it means that you scientists would have access to data that is not available, especially for a region where we don't have a lot of data that you're talking about. We have kids that are involved in active science, meaning that If, for example, you have an organization that is interested in water, you can involve the schools in doing that kind of research. If it's water monitoring, you're able to do that. The kids have indicated that. If it is atmosphere, you're interested, you're able to do that as well. And then, like mentioned by Erica, we have partnerships with SMART program, where kids will be able to collect soil moisture. And then using the data that they've collected, then we'll be able to use, they will be able to compare the data that they've gotten from the satellite and being able to calibrate the SMART satellite. We've already done that with GPM, Global Precipitation Measurement. We're also going to do one with GEOS, that is monitoring El Nino, and we have a field campaign that is also involved in that. So we have a number of initiatives that we're running. We have created the platform. Again, it's an international program. We have 117 countries of data. We have over 135 million measurements so far, which is available on the Globe website. And that data is freely available. You can visualize that data you can visualize it, and you can also download it either in a format that you can use, CSV, Excel format. And again, depending on the region, I know you come from different regions, then you can access that data from, for your particular regions if you have a school. And that is partly what we are trying to do, to encourage as many schools as possible to be involved in the GLOBE program so that we have more data available. And again, that data possibly will be at a good time available to UNEP Live, again, increasing the number of people who can access it for their own research. Thank you very much for your attention. And I want you to give this team of St. Scholastica a hearty clap for their good presentation. Thank you so much.
Sorry, everyone. What I forgot to mention was that Erica was Skyping in from California. It's about 4:30 in the morning there. So she actually did an amazing thing for us. So that's great. I thank the St. Scholastica students and and their professors and Director Mwangi. Thank you very much for showing us the future of citizen science. Thank you very much. And now we will switch the podium over to the co-chairs of the GEO program, and we will look at what environmental assessment is today. So if I could invite our colleagues up for the follow-up of the session. Okay.
So, as the co-chairs and the moderator take their seats, we're going to be a bit flexible because one or two of our final panelists are unfortunately going to leave us. Peter, for example, has to go. So I'm going to, with your indulgence, make a slight change to the timetable this afternoon, if you're okay with that. And to give more time to GEO, I'm proposing that we change the timetable. We now start with GEO. We take the first three, take a small break for coffee, and then come back and do the second three. So you have the opportunity then to go until 5 o'clock. Okay? And then we'll convene after that and have our wrap-up session, if that's all right. Thank you.
Great. Thank you, everyone, for your patience. I'll first introduce the panel here and our moderator, John Matuzak. John is going to give a little bit of an introduction of the process that we're going to go through, and I think we'll first start with Asia Pacific, Europe, and and North America. And then we'll show you the others after the coffee break. Okay, thanks. Over to you, John.
Thank you very much, Pierre, and thank you, Jackie. The GEO has entered a new phase with GEO 6, and we're all very excited about it. In the past, it is, and it will continue to be, and we will, as we go forward from here, be working on the 6th Global Environmental Outlook. However, in order to really accommodate the data and to be able to access the policy solutions that are working in different areas of the world, to identify the particular challenges that are unique to different parts of the globe, this time GEO began with regional environmental outlooks. And we have And we've also entered a new phase where we're doing e-books, but we can't totally get away from our traditional hard copy books. And certainly some of you in different parts of the world have less access to reliable internet connections, and so a hard copy book can be quite useful. But hot off the presses, we have here the regional environmental outlooks, except for the European one, which will be released in about 3 weeks at a Environment for Europe ministerial meeting in Batumi, Georgia. So we have really wonderful work. This is the culmination of literally hundreds, over 1,000 different authors and reviewers of these different regional efforts. They brought together governments and scientists from throughout the world, and specific scientists from each region to put these together. And they have come up with some very important outcomes, and we're going to hear a little bit about that today from each of the regions, and then we will have hopefully some opportunity for some dialogue and questions. We also are very blessed to be able to present the global gender environmental outlook. And so we will have a short presentation on that. I do want to call your attention to the summary of the regional assessments that is available as an INF document for the UNEA meeting, and it is UNEP/EA.2/INF17, and that is the summary of the GEO6 regional assessments. And so I would encourage you to go to that to get further details that fill in some of the gaps that may be identified, or that there is insufficient time to cover in the presentations today. So without further ado, we'll get immediately to the regional reports, and I'm going to ask Peter King to present the Asia-Pacific report. Peter?
Thank you very much, John, and good afternoon, everyone. Where to start? This has been quite a labour of love over quite a period of time. We started off with the Asia-Pacific Regional Environmental Information Network Conference in Bangkok back in April 2015. At that meeting, we had representatives from governments, academia, and various other stakeholders who decided on the top environmental priorities for the Asia-Pacific region. And as you can imagine, the Asia-Pacific region is highly diverse, and to come up with an agreement on what were the top 5 or 6 regional priorities was quite a challenge, but we managed to get there. A little bit later, the first forum of ministers and environment authorities of Asia was held again in Bangkok in May of 2015, and they basically agreed on the priorities that the earlier meeting had come up with. And to quickly give you a snapshot of what the main priorities were, changing demography, lifestyles and access to basic services, increasing inefficiency in the use of resources, increasing vulnerability to the impacts of natural hazards and extreme events, increasing environmentally related health risks, and widening gaps across regional policies and legislation, and particularly the implementation of those policies, which is very uneven across the region. We then assembled a team of experts from across the region in a wide range of topics, and I would like to acknowledge the tremendous work and above beyond the call of duty devotion of these authors to stay with us to the very end. They did a terrific job, and I really acknowledge their contribution. So looking at the state and trends, what we found is that because Asia-Pacific is such a diverse region, sub-regions actually have particular issues that they're dealing with. For example, air pollution is a particular problem in some of the larger countries like China and India, where 8 of the 10 most polluted cities in the world currently exist. Climate change impacts, of course, across the region, but particularly of concern to the small island developing states in the Pacific region. Land degradation is a major issue, particularly in South Asia and parts of China. Ecosystem integrity and biodiversity is threatened in a wide range of hotspot areas across the region, with significant loss of biodiversity documented. And interestingly enough, over the last few years, a number of new species have actually been discovered in areas like Vietnam and parts of Laos PDR. Freshwater scarcity is becoming a particular concern in South Asia, where groundwater depletion is becoming a significant threat to sustainable development in that part of the region. And then across most parts of the region, the coastal and marine ecosystems are also degrading. And you would have seen in the press recently that 93% of the coral reefs in the Great Barrier Reef in Australia, which is where I come from, are currently threatened because of the current El Nino event. And then due to the increasing consumption patterns and the emerging middle class, which is becoming numerically very strong throughout Asia and the Pacific, waste disposal is becoming an increasing concern, particularly with uncontrolled dumping. So, as required for all of the global environment outlooks now, we then turn to the question of what kind of policy responses are options for countries within the region to adopt. And some of the key policy messages that came through are as follows. Firstly, there was a widespread agreement that because of climate change issues in particular, decarbonising development is increasingly important. Decoupling carbon emissions from economic growth is a major policy challenge. And improving resource efficiency for transition to an inclusive green economy. Protecting and enhancing the natural capital and ecosystem integrity across the region. Building resilience to natural hazards and extreme climate events. Responding very positively to emerging environmental health risks, which we heard this morning in the Frontiers report. and strengthening environmental governance for effective policy diffusion at multiple scales, and strengthening the science policy interface and access to knowledge, which is why we're all here at the Science Policy Forum this week, and enhancing international and regional cooperation on climate, air, and other environmental issues that are affecting not only the Asia-Pacific region, but also the teleconnections between regions. And with that, I thank you. And here is the report.
Thank you, Peter, and I think we'll hold questions at least for until the first three. We could take a couple of easy questions depending upon the timing, but we will definitely have questions at the end. I'd like to go to North America next, and Mark Levy is the coordinating lead author from Columbia University in New York.
Thank you, John. Thank you, Pierre, and thanks to all of you for coming here this afternoon. We began our regional assessment with a meeting outside Ottawa, Canada, almost exactly a year ago. And as in the Asia-Pacific region, we discussed what the regional environmental priorities were in the U.S. and Canada. And we also put those priorities in a narrative framework. What we discovered in that meeting was that there were some common concerns over particular changes underway in the region, and there was a desire to have the assessment put those changes into context. Then just a few months ago, we had another meeting with representatives from the Science Advisory Panel and the high-level group to help us, keep us honest, make sure that we were following the guidance from the peer review process and making sure we were living up to the requirements and the mandate of the GEO6 process. So our findings were mixed. We had lots of good news. Some of the good news was surprisingly good. We found progress where we weren't always expecting it. However, we also found lots of evidence of several problems that were unfolding far faster than our ability to manage them effectively. An example of surprising success is in the case of air quality management. The maps in the lower left are comparing 1990 sulfate deposition with 2012. You see not only this legacy of great progress that's a function of the heavy investment and very vigorous policies over the past decades, but what our assessment does is it details that this trend towards effectively regulating air quality has continued up until the present day. And so even though there's a lot of hand-wringing over complications and difficulties in getting effective environmental policy in our region, we find that policymakers are able to innovate and find effective ways to use traditional regulatory instruments, even when there's obstacles in their way, to great effect. However, we find, as I said, lots of examples where problems are emerging in ways that are proving quite difficult to manage using the existing frameworks. And this is a combination of new problems that were not on the regulatory agenda 20 years ago and problems that were on the regulatory agenda earlier, but have the characteristic that they unfold through complex systemic interactions of multiple drivers and complex pathways through which their impacts are felt. And those problems are harder to regulate with the traditional instruments. So the pictures in the middle are showing a harmful algal bloom episode in Lake Erie, which is a problem that we had been making progress on managing. Those numbers were reducing. Now we tend to see more of those. So that's an indication that something that we had been getting good at, we're now not so good at. And then we have these brand new problems, climate change, contaminants of emerging concern. These are things that none of our prior instruments are equipped us to deal with, and they're triggering cascades of problems that are unfolding far faster, more complex ways, affecting ecosystems and human societies in very significant ways that we are interested in finding ways to find better solutions for, because we're not there yet. So the policy messages that we came to reflect this dichotomy. On the one hand, we want to emphasize that the traditional environmental policy tools remain very effective, and so there's no reason to give up on them. In fact, quite the opposite. We see evidence that when you double down and invest more vigorously in those, you get a positive payoff. However, because of these old problems that are getting worse and these new problems that the old toolkit's not equipped for, there's a clear need for innovation. And when we looked at the policy landscape, what we found was lots of vibrant innovation, experimentation, and commitments to results and effectiveness. And so we do our best to try to point out demonstrated, practical, proven approaches to managing some of these complex problems. I tend to think of this as reaching our Yoda moment. Yoda told Luke Skywalker not to try, but to do. And what we see is lots of evidence of people taking solution approaches, adaptive management, participatory stakeholder engagement, natural capital accounting, sustainable consumption and production. These were things that 10 years ago we saw as worthy of trying, but we couldn't quite do them. And now we see lots of evidence of people actually doing them. So the outlook for North America is one in which we could go different directions depending on how the interaction between the new complex problems and the emerging toolkit fit together. We have evidence that in some cases they fit together quite well. In other cases, for example, the water quality crisis in Flint, Michigan, they're not fitting together well. And so the challenge looking forward is to find ways to be more systematic at matching effective new responses to these new challenges. Thank you.
Thank you, Mark. Before we have a break, we have one more presentation. It will be about Europe. Again, I'll remind you that there is not a copy. We have Europe is embargoed, but the summary of the conclusions for Europe are available in the INF document that I presented or that I mentioned earlier. And we have a presentation now. And Diana Mengelage, I'm sure I almost, forgive me, from Oxford University, was one of the coordinating lead authors, and she will present those findings. Diana.
Thanks, John. So I'm Diana Mangalaju, actually, which is a Romanian name, and I co-chaired with my colleague who is sitting there, Nicolae Dronin. We co-chaired this pan-European assessment, regional assessment. So we apologize that indeed our assessment is you can't have it here in hard copy. It's there, believe us, we worked hard and it's delivered, but this was part of the process that it's embargoed and it's going to be launched, as John said, at the Batumi Ministerial Conference. So, do you have a... Oh, sorry. That was too fast. All right, so obviously you are going to see that the regions are having some commonalities in terms of process. So we also started, as the other regions, with the regional information network meeting. We had it in April 2015 in Istanbul, and we, as the regions, tried to identify the regional priorities. Something which is worth noted is that we basically ended up with the same regional priorities as GO5, basically, which are consistent through the regions, and I'm going to come to that in a second. Well, when we talk about pan-European region, everybody knows obviously about the many developed countries in European Union now, but of course it's a quite diverse region in the sense you have the Balkans, you have the Central Asia, the Caucasus countries, Turkey, Israel. So it's quite diverse and in some ways challenging regions. So if you go into, and of course I have to be as quick as possible through this presentation because it's only me keeping you from getting into the break. So trends, demography, well, aging, mostly in Europe, in Western and Central Europe and the Russian Federation. However, in Central Asia, you have quite an increase in the population. So you have this kind of divergent trends even in, sorry, not yet. Sorry. So that's about the region. Of course, also another thing which is a particular pressure in the region is, and the western part of the region, is the migration. Well, this was discussed at length this morning, so I'm not going to come back to that. So as I said, regional priorities. However, on top of these regional priorities, which are climate change, air quality, chemical and waste, biodiversity loss, and fresh water, we had to be sure that we are also taking on board what were the two main themes of the UNEC Committee on Environmental Policy for the Batumi Conference in June. And these are greening the economy, that's one thing, and the second theme is the air quality. So that's obviously quite convergent with the 5 priorities I just talked about. And just 2 months ago, we had the review assessment meeting held in Geneva, where basically the summary for policymakers were put together, and this is something which is available. John just gave you the where to go as the URL for it. So, yeah, can I go next? So, what are the key findings? And I'm going to focus on only some of the key findings, and I'm going to focus on the ones which are really related to the regional priorities I just mentioned. Well, climate change, obviously, not a very big surprise. However, while in the pan-European region you have a number of things which are quite front-running policies, this is definitely not enough, and if we want to meet Paris Agreement goals, more action is needed. And something which is getting now more discussed and was accepted to be one of the important pieces here is, when do we start to include export of the emissions in the targets, basically? And obviously, a lot of progress is needed on the adaptation measures. So that was about climate change. Air quality, while a lot of progress happened in the region, now it's a kind of saturated in. Most of the pan-European population is exposed to air quality problems, and it's really today the largest health risk in pan-Europe. Current legislation is quite advanced, and more is getting into that. However, our analysis shows that only slow progress is going to be done when we go to further, 2030 and beyond. Biodiversity loss, it's quite a problem, and ecosystem degradation, obviously that's habitat fragmentation, intensification of the agriculture, still urbanization trends, even if it's quite urbanized regions. And however, we have also some positive trends. It's always, as you could have heard from Mark just before, we have challenges, but there are quite a number of positive trends in the regions. Chemicals and waste, well, at the European union level, there are quite a number of issues which are well managed. What is quite interesting on some of this regulation is that even without being absorbed as regulation in some of the other non-EU countries in the regions, they basically get a kind of contagion phenomena and they spread towards the east, particularly towards Central Asia. Well, quite a number of things, and that's something we featured quite a lot. It's emerging issues in terms of chemicals, hazardous products, and accumulation of biochemicals. And freshwater, well, globally speaking, it's improving. However, big differences, particularly linked to the level of development in the region in terms of access to sanitation and also to drinking water. So, if I move now to some of the key policy messages we have for the regions, well, one of them is really linked to the natural resources. The region, pan-European region's footprint in terms of resources is unsustainable. We have overuse of resources and, well, quite significantly it comes from the trading patterns with the other regions which are presented here. Well, that's one thing, of course, and we have been hearing that since this morning in the sessions about the connectivity of these challenges. And really, and this is getting actually quite a lot into the agenda, but needs to get there even more. It's how to get more integrated policies in a way that we have to get, at least in the pan-European region, to absolute decoupling, not only to relative decoupling in the regions, and how to really reduce significantly the natural resource use. One thing which we think it's important to feature is that we don't think, based on the analysis we've done in this assessment, we don't think that technology will fix it. So technology is needed, but it's not going to get us there. Environmental policies obviously needed. Neither environmental policies nor technology, we don't think these two pieces alone can fix it. So you need really to go beyond and to improve integration and also to tackle all the distributional aspects and the environmental justice aspects which are getting more and more prevalent in the regions. Lifestyle changes, well, particularly we are talking about quite developed parts of the world here in the region, so how that can get even more into the policies, and that should be really a prioritization in the policy domain, so that tackle the resources at their very source. And also, once more, so he said we identified quite a number of emerging risks and emerging issues, which we'd like to see, and we encourage policymakers to bring more early on the policy agenda. And finally, well, non-governmental actors and more coalitions of quite hybrid kind of coalitions, we think. We can see that happening, a lot of bottom-up, very interesting things, some of them based on technology and particularly IT, some of them on coalitions in between businesses and non-businesses, profit and non-profit, but basically going beyond a bit the usual governance arrangements in the region. I stop here. Thank you very much.
Thank you, Diana. And you weren't the last thing holding them from coffee, because coffee isn't ready, and the instructions we got from Jackie said at 1:45 we can break for coffee. And I will actually do that if, in fact, you all promise to come back, because we have some exciting reports that we're going to continue on, including Africa, West Asia, and Latin America and the Caribbean. So do come back. However, before we break, I want to give an opportunity to incorporate and gender issues into our discussion and present something on that. And so in addition to all of the regional work that will serve as a foundation, UNEP also undertook a global gender environmental outlook. And to present that, we have Joni Seeger, and she will give us a taste of that. And after that presentation, we can then go for coffee. You'll have about 15, 20 minutes, and then please come back. Thank you.
Yes, right. Right, now I'm holding you back from coffee break, but I'll try and make it worth your while. So thank you very much. I'm honored to be here to present really just a peek at the GGO report, partly because of time and partly because the official launch isn't until next week. So why a gender and environment assessment? Well, in the most simple answer is the network of women ministers and leaders for the environment requested that UNEP undertake this, but also the time is right. We have now a critical mass of gender analysis and scholarship and activism. GGO parallels and complements and is in conversation with the GEO process, and also, frankly, gender is a complicated and big enough topic to warrant standing on its own. As I said, there is a substantial body of evidence and analysis already available on the depth and breadth of gender-environment nexus. GGO is very much standing on the foundation of path-breaking work of literally hundreds, if not thousands, of scholars, practitioners, community groups, and gender activists. But therefore, why GGO? Well, partly because this information done by these hundreds and thousands of scholars and practitioners and advocates is scattered and incomplete. So GGO's distinctive place and its distinctive contribution is that it aims to be comprehensive and global. Further, we make a substantial contribution to environmental assessment by foregrounding a new synthetic methodological framework and a new matrix of inquiry. Matrix of inquiry just means we ask different questions, but it sounds so much more official if you say matrix of inquiry. So gendered environmental analysis is not just a matter of adding women and stirring. In fact, it's primarily not about adding women at all. The goal is really to bring a gender lens to environmental assessment, making both men and women visible as actors, and also making visible the gender norms and frames that are environmentally instrumental. So, for example, some of the new questions we would ask in an environmental assessment, a traditional question would be, what social forces are producing environmental change? And we would say, what social forces are producing environmental change, and are they gender dependent, or are they gendered? What are the consequences of ongoing ecological changes for social systems and human security? And again, are those gender differentiated? I won't go through all the questions in the interest of time, but just to say we also in GGO took a slightly novel approach for environmental assessments. It really puts humans at the center of the assessment. We drew on a very diverse mix of sources, of course relying on kind of the conventional scientific reports, but also bringing in cultural analysis, combining macro and micro data with a great deal of interest in the daily lives of men and women, and incorporating questions about the construction, the social construction of knowledge, and the perception and how we know what we know and how that influences how we act in relation to the environment. Getting to GGO is a very large, complicated process. It was a diverse process involving academics, civil society representatives, government advisors, major groups, and a dedicated and impressive team here at UNEP. Almost 50 experts contributed to the writing and about as many again in reviewing. We have prepared an abridged version of GGO specifically for UNEA 2 to be launched next week, with the full report to be following shortly thereafter. So, key messages in very, very brief. One, all dimensions of the environment are gendered. Gender roles and norms position women and men differently in relation to the environment. So whether you look at drivers, impacts, perceptions, pressures, actions, knowledge, policy-making processes, they are all gendered. And when you look at perceptions of environmental risk or impacts of disasters or consumption patterns, these too are gendered. And I want to just give you a very quick example of a novel way or kind of new information that a gender analysis gives you. So this chart shows the percent of women interviewed in a small sample of countries who said they directly handle pesticides. And I'd like you to look at the left end of the graph, particularly Armenia and Belarus. A very small number of women said that they directly handle pesticides. However, the percent of women who say they don't handle pesticides but who wash pesticide-contaminated clothes by hand in those same two countries is 39% and 25%. So you have different pathways to exposure. I'm going to quickly just skip through a couple to get to the second key message, which is data. Data, data everywhere. We need more of it. We all know that what gets counted counts, and there is a terrible paucity of gender disaggregated environmental information, and we have new opportunities ahead of us with the SDGs to start to write that, to start to fill out that data matrix. We also want not just more data, but better data, and particularly lift the roof off the household. Households, we know, we know this, that households do not make decisions, nor do they have education rates or literacy rates or water usage or health outcomes or property rights. Households don't have those things, and yet most social environmental data are collected by household. In truth, it is inside households and in a context of gendered negotiation inside households that critical environmental decisions are made about resource use, priorities, consumption, coping strategies. So we really need to examine intra-household dynamics. Just a couple more key messages. We need gender-sensitive environmental assessments at national and international levels. We would recommend that there be gender impact assessments, perhaps even made mandatory in public and private environmental reviews and permitting. And we really need a national level state of gender in the environment assessment to help establish a baseline context. Key message 5, this is self-explanatory. Existing commitments, gender commitments, of which there are many, just really need to be followed up and implemented. Enough said about that. What next? I would say that moving forward post-GGO is a shared responsibility. UNEA 2 is a key forum for strategizing, and the official launch of the GGO, the critical issues, this abridged version, is next week for those of you who might be around, Wednesday at 9 a.m. And thank you very much. This is a wonderful picture of course we know Wangari Maathai and Lena Somstedt, the Minister of Environment for Sweden, at the moment that she had been told she'd won the Nobel Prize. Thank you very much.
Thank you, Joni, for that really important message, which we need to continue to reinforce. I recall working on the delegation to the 6th meeting of the Commission on Sustainable Development in 1998, where the theme was water. And there was we had a discussion about gender disaggregated data there. And several countries said, well, why? And fortunately, our USAID program had some really wonderful examples, one from West Africa and one from India, where they went out and did household surveys and did individual surveys, gender disaggregated surveys, about the relative priority of putting a standpipe for water in a village. And they asked the women, how much water actually are you using? And they asked the men the same thing in your household. And invariably, the women came to almost within about a milliliter of the amount of water that was being used. They knew. They and their daughters carried it all to the household, and they used it. The men, they were way off. they almost invariably underestimated the amount of water that the household was in fact using. And in fact, they were much less prone to invest and use the local resources from the community to invest in a standpipe. So I'm glad that we are continuing to draw attention to this critical piece, and that hopefully we will mainstream it even more while we also take a look at it independently. We're going to break now. I'm going to hold questions so that you come back. We'll have 3 presentations, and then we have sufficient time. Thank you, Jackie, for providing us with sufficient time so that we can, in fact, have an opportunity to interact and ask some questions of the lead authors here, and to look at some commonality amongst all of the regional reports, and you can ask Joni questions as well. So when we come back, we will again have Africa, we will have West Asia, and we will have Latin America and the Caribbean. We have a break until 4 o'clock. I'd ask you to be back in your seats at 4 so that we can continue. Bring your friends, but don't leave us, and we will have, I'm sure, a very interesting discussion. Thank you very much.